In this section, we'll talk about how clothing is used to support life inside a spacecraft environment and what new environmental factors need to be taken into account to design effective IVA clothing. Inside a well-developed spacecraft, the ambient environment is usually pretty similar to indoor environments on Earth. Astronauts on the space station pick their own clothing to bring on a mission, and it usually looks pretty similar to everyday clothing. The temperature on station is set by the mission commander, so everyone else adapts to that person's preferences. Sometimes that means that if you're a smaller or colder person, you might need an extra layer. You'll notice that crew members don't really wear shoes. They're not really needed when you spend your days floating. You'll also notice that clothing tends to be tucked in. In microgravity, clothing doesn't get pulled down by gravity, so it tends to float around the body. Tighter fitting clothing also helps keep clothing in place. As we discussed in the extraterrestrial environment section, microgravity can have negative effects on bones and muscles that are used to working against Earth gravity. To help counteract this, crew exercise for 2 or 3 hours a day. As you can imagine, in an environment where you float away from everything that you push on, it can be tricky to stay in place. Some exercise equipment on station uses harnesses and tethers to keep the crew member in contact with the exercise equipment. And because clothing doesn't get held against the body by gravity, looser fitting clothing may not be in contact with liquids. For example, if you designed a wicking t-shirt for astronauts, it would need to be very tightly fitted to make sure that the fabric stayed in contact with liquid sweat in order for it to be useful. I should mention, though, that the principle that wicking operates by, capillary action, it does work the same in microgravity as it does on Earth. So what do they do with all that sweaty gym clothing? Unfortunately, washing clothing with liquids, as we do on Earth, is not really feasible in space. Currently, astronauts wear their clothing until it's too dirty to keep wearing, and then they throw it away. It's put in a garbage transport and it's burned up on their return through the atmosphere. Crew bring as little clothing as possible because every ounce of cargo adds a lot of expense to the mission. Underwear are worn for 3 or 4 days, and things like shorts or socks might last for weeks. As missions get longer, it's likely that new ways to clean clothing will be needed. Some of the non-liquid-based cleaning methods that we discussed in the hygiene module might work. Another clever way to reuse dirty laundry was explored by astronaut Don Pettit during an ISS mission. Don was interested in seeing if he could grow tomato and basil plants on station as a side project, but he didn't have permission to bring things like dirt. Instead, he sprouted his seeds in a pair of dirty underwear wrapped in space toilet paper. Most of the crew's time on station is used to do work, either to maintain and repair the station itself or to carry out science experiments for scientists on the ground. As they work, their clothing also serves to support the tools and objects that they need. Here you can see 2 crew members wearing their documentation, manuals and procedures for the activities that they're involved in. Crew clothing usually comes with Velcro stripes that are used to attach objects. The station also has Velcro strips in many places so that objects can be set down securely. Here, Mae Jemison is wearing her toolkit on her leg. Clothing in microgravity also needs to account for stored objects. On Earth, most pockets don't actually close. They're there so that we can slip things in and let them be held by gravity. In microgravity, objects will float out of pockets if they're not sealed or secured, so you'll see that most astronaut pockets have some kind of closure. Small objects can be particularly difficult in microgravity because our eyes aren't good at finding things in mid-air. In just the same way that a spot on your glasses becomes invisible to your brain, your eyes will focus on things that have sharper contrast or more discernible edges. It's impossible to force your eyes to scan through depth, to focus closer and farther away without an object to fixate on. So if you let go of a screw or something similar in microgravity, something that's small and has low contrast and isn't moving very fast, it can be impossible to find until you actually bump into it. Crew don't often wear elaborate control technologies, but this is an example of a more complicated wearable system. Here, Karen Nyberg is wearing the controls for the Robonaut, the humanoid robot system. You can see that cable management is a problem in microgravity, just as it is on Earth. Communication on the station can be a challenge because of its size. There is a public address capability, but if a crew member has a message for just one other person, they often have to go and find them. There's no way to contact them directly from a distance. Because the station is a maze of tubes that stretch over the length of a football field, that can be time-consuming. Clothing and wearables can also help monitor the status of the crew. There are many reasons why it's important to measure what's going on, particularly for long-duration missions where it might be necessary to make sure that nobody is getting sick. Because the space station is a totally isolated environment, to date nobody has ever been sick in space. Crew are screened really carefully and isolated before launch to make sure that no viruses are introduced into the station environment. But on longer-term missions, health issues could build up over time. Right now, crew often wear devices that are related to a specific study, like this system that was used to measure circadian cycles and sleep on station. The shirt on the right is AstroSkin, which is a Canadian Space Agency project that's looking at building biomonitoring into an undergarment.